guys, welcome to this module of Basic Engineering Mechanics. In this module, we'll be learning about uh, how to express the three-dimensional force in terms of rectangular components, and we'll make the use of dot product to find the projection of a force vector. Okay, so let's get started. Okay, so in the representation of a force vector, we have to first of all determine the position vector of that particular force. So we have to walk from the tail to the head of the position vector AB, and then we have to find the unit vector along the position vector, and then we'll multiply that unit vector with the magnitude of that force to find out the position vector of that force. Okay, so suppose this is a example I have taken, and in this example I have shown you two forces, one is F and one is P. I'll do that thing for one force, and I'll request you guys to just on your own try to do that for the force P. Suppose F is of 260 newtons, okay, and P is of 100 newtons. Take this basic value, and for the force F I'll try to draw it, and then for the force P you should draw it by yourself. Okay, so what the first thing is, you have to walk from the tail to the head of the vector. Okay, in this case we have to move from the point A to point B. Okay, so the tail is point A and the head is point B. So for moving from A to B, we have to move for this position of the AB, we have to move negative 4 units in x direction. Okay, that is 4I. Then we have to move plus 12 units in j direction, that is plus 12j, and then again we have to move plus 3 units in z direction, 3k. So this is the position vector of this force F. Okay, now the next step will be to find out the unit vector along this position vector. This was the position vector. To find the unit vector, we have to first of all find out the magnitude of this force vector AB. So to find the magnitude of this vector AB, what we have to do is take the square root and sum of all the individual x direction unit, y direction unit, and z direction unit. That is minus 4 square plus 12 square plus 3 square, and that you will be getting as 13. Okay, so 13 is the magnitude of this position vector. Okay, so the unit vector along this position vector will be the position vector AB divided by the magnitude of this position vector. So that will be 13 was the magnitude, so minus 4 over 13 times I plus 12 over 13 times j plus 3 over 13 times k. Okay, so this is the unit vector along the direction of the force F. Okay, so the next step we'll find the force vector. So what we have to do, we have to simply multiply this force magnitude by this unit vector. So the magnitude, if you recall, the magnitude was 260 newtons. Okay, so the force vector F can be written as minus 4 by over 13 times of 260, that will be 80 in the I direction, plus 12 over 13 times 260, that will be 400 actually, sorry, j, plus 3 over 30 times 260 will be 60k. So this will be the final force vector in the direction of AB. Now I would request you to try to write the position vector for this force, which is P and which has the magnitude of 100 newtons. Try to do this on your own exercise and you'll have a clarity about this thing. Okay, so the next thing is the dot product to find the components. Now the definition of dot product says, if you have to take the dot product of two vectors A dot B, that will be the same as B dot A. So that will be equal to magnitude of vector A times magnitude of vector B times cosine of angle between them. Okay, so suppose there is a vector F and you have to find the projection of this vector in the direction of vector Q. I'm talking about this. So you have to take the dot product of this vector F with the unit vector along Q direction. Now we already know how to find the unit vector. That will be equal to the unit vector F, vector Q, pardon, to mod of vector Q, and you will get the value of unit vector along vector Q. So the projection of this force along the direction of Q will be F times U, that will be equal to mod F. Mod U will be 1 because it's a unit vector, and cos theta. So that will be the projection of this force F in the direction of vector Q. Okay, so that sums up this module.